Welcome back to the channel. Today we're diving deeper into stoichiometry by tackling two concepts to make real chemical reactions behave less perfectly than our balance suggestions, limited reactants, and percent yield. We'll start by understanding how one reactant can run out first and stop a reaction in its tracks, just like running out of a key ingredient in a recipe. Then we'll connect that idea to percent yield, where we'll compare what should happen on paper to what actually happens in the lab. By the end of this lesson, you'll know how to identify the limiting reactant, calculate theoretical yield, and determine percent yield for any reaction you're given. Let's get started. In our first problem, we're going to identify the limiting reactant in a simple problem. Okay, so the reaction is we have potassium bromide plus chlorine to produce potassium chloride and bromine. Okay, we're given that we have 2.54 grams of chlorine and 15.8 grams of potassium bromide. And we need to know which one is limiting. But before we get started, we need to balance the equation. So I have to have 2 potassium bromides, 2 potassium chlorides. So what we want to do is, let's take potassium bromide and let's solve for the amount of chlorine. So I would have 15.8 grams of potassium bromide times 1 mole potassium bromide over, okay, so potassium is 39.1, bromine is 79.9, so that's 119 grams potassium bromide. I have 1 mole of chlorine. This is my ratio step, over 2 moles of potassium bromide. I have 1 mole of chlorine, and chlorine is 35.45, so 2 times 35.45 should give me 70.9 grams of CO2 per mole. Okay, so grams KBR cancel, moles KBR cancel, moles CO2 cancel. Well, this would give me 4.71 grams of CO2. So I need 4.71 grams of CO2. I have 2.54 grams of CO2, which means I do not have enough CO2 to react with 15.8 grams of KBr. So therefore, my limiting reactant will be CO2 because it's going to run out before the KBr runs out. So if I have just 2 reactants and nothing else given, I simply take one and solve for the other. I look at how much I have and how much I need and compare those two. In the reaction, barium carbonate plus nitric acid to produce barium nitrate, carbon dioxide, and water, what mass of barium nitrate can be formed by combining 55 grams of barium carbonate with 26 grams of nitric acid? So I have barium carbonate plus nitric acid. It's going to produce barium nitrate. Plus carbon dioxide plus water. Okay, to balance this, all right, let's label what we're given. We're given 55 grams, yes, 55 grams of barium carbonate. We're given 26 grams of nitric acid, and we're solving for the grams of barium nitrate. So the logic is, let's take nitric acid and solve for barium nitrate, and let's take barium carbonate and solve for barium nitrate. Whichever gives me the lowest value will be the correct one, because one of these reactants are going to run out before the other one. So I'm going to start with the barium carbonate, so it'll be 55 grams. Convert it into moles. Okay, barium is 137.3. Carbon is 12. 3 oxygens is 48. So that gives me 197.3 grams. Barium carbonate. My ratio step, I'll have 1 mole of barium nitrate per 1 mole barium carbonate. Let's convert 1 mole of barium carbonate, barium nitrate, into grams. Okay, so this is 137.3 plus 2 times 14 plus 6 times 16. That should give me 261.3 grams. Okay, let's solve this. This should give me 72.8 grams. Okay, let's do the same thing with the nitric acid. So I have 26 grams. Convert that into moles. Okay, hydrogen's 1, nitrogen's 14, plus 48, that's 63 grams. Okay, the ratio step will be 1 mole of barium nitrate per 2 moles of nitric acid. And again, we're using 261.3 grams barium nitrate per 1 mole. Okay, this will give me 53.9 grams Okay, this value is much smaller than this one. So that means then that my limiting reactant was the nitric acid, which means I had an excess of barium carbonate. Carbon disulfide is reacted with 67.5 grams of chlorine to produce carbon tetrachloride and 39.5 grams of disulfur dichloride. What is the percent yield for the reaction? Okay, let's go ahead and write out the equation. So it'd be CS2 plus Cl2 gives me CCl4 plus S2Cl2. Okay, let's balance the reaction. So a 3 goes here. Let's label what we're given. We have 67.5 grams of chlorine and 39.5 grams of disulfur dichloride. Okay, so I'm going to take this and solve for this. So we'll have 67.5 grams of chlorine. Pour that into moles. Okay, chlorine is 35.45 times 2. That will give me 70.9. My ratio step, I would have 1 mole of S2Cl2 per 3 moles of Cl2. Okay, sulfur is 32, so it'll be 2 times 32 plus 2 times 35.45. That will give me 134.9. If I solve this, I would get 42.8 grams of S2Cl2. The formula for percent yield is the actual yield divided by the theoretical yield times 100. So that's equal to, okay, my actual yield was 39.5. My theoretical yield is 42.8 times 100. So this would give me 92.3% yield. Remember, the actual amount is on top. And when I solve stoichiometry, this would give me the theoretical yield, which goes on bottom. In this problem, we're going to combine the concepts that we learned in the first 2 problems. So we're combining potassium plus oxygen to produce potassium oxide. Just balance it. I need 4 potassiums, 2 potassium oxides. Just label what we're given. We're given 6.92 grams potassium. We're given 4.28 grams of oxygen. And we're just told that it's producing 7.36 grams of potassium oxide. We need to determine who is limiting. So we're going to solve for both of these. Whichever gives us the lowest value will be the limiting reaction. So I'm going to start with potassium. I have 6.92 grams of potassium. Convert that into moles. 1 mole of potassium is 39.1 grams of potassium. Times my ratio step, I have 2 moles of K2O per 4 moles potassium. Let's convert this into grams. 1 mole of K2O. Potassium is 39.1. I have 2 of those plus 16. This is going to give me 94.2 grams of K2O. When I solve this, it's going to give me 8.34 grams of potassium oxide. Now using the oxygen, 4.28 grams. Convert it into moles. Oxygen is 16, so 2 times 16 is 32 grams. Times the ratio step, and 2 moles of K2O for 1 mole of oxygen. And again, this is 94.2 grams of K2O for 1 mole of K2O. All right, when I do the math, I get 25.2 grams of K2O. Okay, this one is much smaller. Since this is the smallest, that means this is my limiting here. So this is limiting. Now we're ready to solve for our percent yield. My percent yield, the actual over theoretical times 100. So my actual was given in the problem, so that's 7.36 grams. My theoretical was using my limiting reactant, so that would be 8.34 times 100. That gives me 88.2% yield. How many grams of oxygen would be produced if 137 grams of carbon dioxide reacts with an excess amount of water to produce glucose and oxygen with a percentage yield of 63.4%? All right, so I have CO2 plus H2O yields C6H12O6 plus O2. Okay, let's balance the equation. So I'll need 6, 6, and 6. Let's label what we're given. I'm given 137 grams of CO2. And I'm looking for grams of oxygen. But I'm also given that I have a 63.4% yield. So what we must do is we must solve for our theoretical. So we'll take our 137 grams of CO2 Okay, so CO2 is 44 grams CO2. Our ratio step, I have 6 moles of O2 per 6 moles of CO2. And 1 mole of oxygen is 32 grams for O2. This gives me 99.6 grams O2. This will be my theoretical. So my percent yield is actual over theoretical times 100. So this would give me 63.4. It's equal to actual, which I do not know. I'm going to place an X there, over my theoretical, which is 99.6 times 100. Divide both sides by 100. I will get 0.634 equals X over 99.6. Cross multiply. X is going to be 0.634 times 99.6. So my actual yield will be 63.1 grams of O2. This is my actual. How much potassium chlorate is needed to produce 150 grams of oxygen by the decomposition of potassium chlorate when an 85% yield is expected? So let's write the equation. So I have KClO3, potassium chlorate, is decomposing with heat to produce potassium chloride plus oxygen. I'm looking to obtain 150 grams of oxygen with an 85% yield. So, my percent yield is equal to the actual over theoretical times 100. That gives me 85% is equal to the actual yield, which is 150 grams. I need to solve for the theoretical. So I'm going to put an X there for that one. Divide both sides by 100. So we get 0.85 is equal to 150 over X. X here will be equal to 176.47 grams. That's going to be my theoretical. I'll take this theoretical amount then and solve for the amount of potassium chlorate needed for this reaction. So I have 176.47 grams. Okay, that will be grams of oxygen times 1 mole of oxygen over 32 grams oxygen. On ratio step, I will have 2 moles of KClO3 over 3 moles of oxygen. Potassium is 39.1. Chlorine is 35.45. 3 times 16 is 48. So adding all that together, I should get 122.6. This will give me 450.73 grams of KClO3 needed. Thanks for watching. Today you learned how limiting reactants control the maximum amount of product a reaction can make and how percent yield helps us measure how successful a reaction really is. If this video helped you understand stoichiometry a little better, be sure to like the video, subscribe, and share it with someone who might need it. I'll see you soon in the next lesson. Thank you and goodbye.